Chris here. So tonight's video is about, I say tonight, it could be this morning when you're watching it, is about simplifying algebraic fractions. We're going to start really basic and then build it up to the quadratic ones. So a couple of things to point out is that you are trying to, obviously, when you simplify a fraction, you're trying to make it as easy to communicate as possible. Smaller numbers, less letters, that is the goal here. So what we want to be doing is what's called factoring out. Seeing, on B, is there anything that I could factor out of both 45 and 60? And hopefully you're sat there going, well, obviously it's 15. So what we're going to do is we're going to divide 45 and 60 by 15. So that'll leave myself with 3/4. Now what else I'm looking for is, does my fraction have anything else that it also shares that could cancel out? So thinking about, if I do a over a, those two things will cancel out because technically a divided by a is 1, and we don't write that, do we? And also, when you think about your laws of indices, when you're dividing things with the same power, that would end up giving you a to the power of 0. And remember that anything to the power of 0 is 1 because anything divided by itself is 1 as well, okay? So definitely a and a will cancel out. We don't have to write those again. And b will cancel out. Then that leaves us with c on the bottom of the fraction, so that will remain on the bottom of the fraction. So therefore we're left with 3/4c. So if we look at c now, and we're looking at what can we factor out of these two. And if ever you're unsure, just start it real easy, start it real basic. What can you take out of 16 and 18? Well, definitely 2. I'm going to start off by taking out 2. So if I do 16 divided by 2, that gives me 8 over 18 divided by 2 gives me 9, but I've still got mn over n. So the n's will definitely cancel out, won't they? And then I'm just left with m on top of the fraction. We can't simplify that any further, so we leave that as is. Okay, for f, when we're looking at f, definitely focus on your numbers first. What can you factor out of them? Or even better, can you just divide them? Well, 8 divided by 2 is absolutely 4. So I know for sure I've got 4 on the top. Remember your laws of indices, like we spoke about over here, that if your bases are the same, you subtract the powers. So we can do x to the power of 4 divided by x to the power of 2. Well, 4 take away 2 is 2. So I'm going to be left with 4x squared on top of that fraction. Ideally, you do not want a negative number on the bottom of your on the bottom of your fraction. So if it's going to go into a negative number, just cancel out however many there are on the top. So for example, on G, both of these are divisible by 11. So we've got 3/4, but then we've got a squared divided by a cubed. So what we're going to do is cancel out the two a times a's, which will leave us taking out 2 of those a times a's, but we're left with 1a on the bottom so far. And then we've got b squared divided by b. Well, 2 take away 1 is, of course, 1. So then we're left with b on the top. Okay, fantastic. Moving on to the next slide. And remember, if you need to pause and repeat any of this video, please do that. Okay, so the next thing that we need to do is, of course, look at our fraction here. So it's a bit more expansive because we've got a bit more going on. Again, just look to factor out there. So what can you divide 9x, negative 12, and 3 by? And hopefully you're telling me that it is 3. So obviously 9x divided by 3 is 3x. Negative 12 divided by 3 is negative 4. And 3 divided by 3 is 1. Of course, the fraction line or the vernacular means divide by 1, which we don't write anyway because it's just a whole number. So that is, of course, still valid as 3x take away 4. Okay, up next is this one. So we've got quite a lot more going on here. So let's take it a step at a time. So the first thing that I'm going to do is factor out the 5 where I can, because I can do 10 divided by 5, which is 2, plus I can do 15 divided by 5, which is going to be 3. Take away at the end, I've got negative 30 divided by 5, which is 6. So now what I can do is fill in my gaps. Okay, so I've done the 5, I've taken the 5 out of each one. And what I'm now going to do is try and remove an x from each one. Well, x to the 7 divided by x is just x to the power of 6. I've got x to the 5 divided by x, which is x to the 4. Again, taking away those powers. And then at the end, I've got x to the 4 divided by, I nearly said subtract that, divided by x, which is going to leave me with x to the power of 3. That would be our final answer. Technically, again, you could write over 1, but like I said on the last one, no point in writing over 1. Okay, fantastic. So we'll take it even further now, and what we've got is double brackets on the top and bottom of our fraction. Remember, we're looking to factor out, or we're looking to, what have we got on the top and the bottom of the fraction that's the same? So here, you know, you've got x plus 2 and x plus 2 that are both matching up. So you can cancel those two things out straight away. And then you're left with x take away 3 over x take away 9. Now what you might be thinking is, oh, can I take away, or can I not take away, sorry, can I factor out a 3 of each of these? Technically you could, but then you'd also have to divide the x by the 3 and this x by the 3. So that wouldn't work as nicely as what you think. And same with the x's. Again, could you take out both of the x's? Well, yes, you could, you know, you can divide by what you want at the end of the day. And that would cancel out those front x's, but then it would bring in the extra problem of you'd be dividing -3 by x and -9 by x as well. So that wouldn't work as nicely as what you might be thinking there. So we would just leave our answer as that fraction. Moving on up, so have a look at this question now and think about, well, how does this question relate to this question? And hopefully you start there thinking, okay, this is the factorized version or a factorized version of a quadratic, and this is a quadratic. Now, if we're looking at these instantly, we've got to be thinking, well, they are not going to cancel out. They're not going to change. So we need to change them in some way. And what we can do is factorize the top and bottom. So I'm going to do that for this one. So if I factorize the top, I'm looking for numbers that multiply to 15 and add to 8, which hopefully we know is x plus 3 and also x plus 5. Usually with these questions, you know, if you're being asked to simplify something, something will cancel out. So in your head, you should already be preloaded with the fact that either at the bottom, it's going to be x plus 3, or at the bottom, it's going to be x plus 5. Now, given that we've got to multiply to -12, I don't think that the plus 5 is going to get there, okay? It just doesn't times 12, does it? So we can already, at the bottom, be writing x plus 3, okay? And then we've got to think about, well, I've got to times, or multiply rather, to -12 and add to -1. So what would I times by +3 to make -12 is -4, and then just check to yourself, does -4 plus 3 make -1? Yes, it does. So boom, there is our answer. But that's always a good thought to preload yourself with, well, what could be at the bottom? And then we're not quite finished, of course, because, you know, these two will cancel out as they're both x plus 3. And then your final answer would be there, x plus 5 all over x plus, take away 4. Okay, last question before I give you guys some questions is this one on the screen. So this one on the screen, again, it's going to need some factorizing, isn't it? Everything logically, like technically we can factorize both of them, but we want to be factorizing the easier one of the two. So when we're looking at factorizing these, we'll go for the top first, just because we're not going to have to obviously multiply the coefficient by anything. So we're going to have, obviously, multiply to -8 and add to -2. So if you think about your factors of -8, you've got 1 multiplied by -8, -1 multiplied by 8. Do either of those add to the 2? No, it's not going to be those two, is it? Okay, so then we've got 2 times -4 and also -2 times 4. Do either of those add to -2? Yes, they do. It's this combination, isn't it? So I'm going to have x plus 2, and then I'm also going to have x subtract 4. Now, if we're not sure if either of those are going to be at the bottom, then what we can do is still factorize that bottom bit. So in terms of, obviously, multiply those two together, so you know that you're multiplying to 6, but adding to 7, and those values should be 6 and 1. So then when we've got that, before we go to split the middle, we've got 3x squared plus 6x plus 1x, or just x, and then plus 2. Split that middle up and factorize. So that front bit is going to be 3x bracket x plus 2. And then hopefully on this side we'll also be getting x plus 2. And then we've got, well, we can take 1 out of these, bracket x plus 2. So that's definitely going to work. And then our bracket's going to be 3x plus 1, bracket x plus 2. Hopefully this should be a big sigh of relief because we can see we've got x plus 2 there, we've got x plus 2 there. So these are going to cancel out. So I've got 3x plus 1. And then I've also got x plus 2. Okay, so now I can cancel these two out. And then I'm nearly finished. I just need to write my final answer, which is going to be x subtract 4 all over 3x plus 1. Okay, I hope this video was really useful for you. I'm going to show the questions onto the screen now. Again, you just pause it. But these are your questions. Some of them we have already done, but there are plenty there for you to practice at. And obviously, if you do have any questions about them at all, please email the maths department. Any of us will be more than happy to help you. I'm going to click on your answers now. And your answers are all just here. Okay. You guys have a great day, and I'll see you soon. Thank you. Bye.